Junior Science.
Hello, young neighbors. Welcome to Junior Science. Today we're going to talk about a fascinating subject, fire. We know that fire can be destructive or useful. But what exactly is a fire? Well, first let's see what we need in order to make a fire. We need something that burns, fuel. And we need something to make the fuel hot enough to burn, sufficient heat. But that's not all we need. Here's something that's on fire. Let's put a cover over it and see what happens. So we see that something besides fuel and heat is necessary in order to have fire. What is that something? Well, it's a gas that's in the air all around us, and it is called oxygen. Now, oxygen itself doesn't burn, but it is needed for all other things to burn. You see, burning is a combination of something that will burn, a fuel, with oxygen, accompanied by light and heat. Now, the amount of heat that is needed to start a fire depends on what is being burned. Some things need a lot of heat in order to catch fire. And some things, like phosphorus, can catch fire with practically no heat at all. The kindling temperature of phosphorus is so low that it will almost catch fire at ordinary room temperature. That's one of the reasons why phosphorus is always stored under water, and why it must always be handled with tongs and never allowed to touch your skin or clothing. Even when we cut it, we must cut it underwater, as we are doing here. When we take a piece of phosphorus and lay it on a bottle cap floating in a pan of lukewarm water, the heat of the water brings the phosphorus to its low kindling temperature almost immediately. And it catches fire. Some materials, when they are heated, release their own oxygen. And if you put them on a thing that can burn, that thing will burn even if it gets no oxygen from the air. And if it does get some oxygen from the air, it will sputter and burn even faster. One of the things that releases oxygen when heated is potassium nitrate, which you can get at any drugstore. And knowing its habits, there's a very exciting game you can make with it. First, dissolve all the potassium nitrate you can in a small glass of water. Then use the solution as ink and draw 3 lines like this on a sheet of rough paper. Use a straw to draw the lines so they'll be good and thick. Now what you are drawing is a horse race game, and here's how you play it. Wait a few moments until the paper is dry. Then pick the one you think will win among the 3 horses, number 1, 2, or 3. Now get 3 people with lighted cigarettes to put the end of the cigarettes on the starting marks. Ready, set, go. Watch the horses run. The potassium nitrate makes its own oxygen, which helps the paper burn faster and sputter along to the finish line. And the winner is number 2, with number 3 second and number 1 last. Now that we know how fires are made, let's do some experiments to see how they can be put out. Since fire, in order to continue burning, needs 3 things, fuel, heat, and oxygen, by taking away any one of these 3, we can put out a fire. One of the best fire extinguishers is water. Water is a good firefighter for 3 reasons. First, it won't burn. Second, it smothers the flame by not letting oxygen get to it. And third, water absorbs heat into itself, and so it cools the thing that is on fire. Weight by weight, water can absorb more heat than any other common substance. To prove this, you can take 2 glasses, one containing water and the other containing another substance that is used to put out fires, carbon tetrachloride. Soak a matchstick in each glass. When both matchsticks have been soaked thoroughly, hold them over candle flames. Water absorbs so much heat that the match soaked in carbon tetrachloride will burst into flames before the water-soaked match even begins to char. Another popular fire extinguisher is a gas called carbon dioxide. And here's how you can make this gas for yourself. Put half a teaspoon of baking soda in the bottom of a glass. And pour a little vinegar on it. The two react chemically and give off carbon dioxide. Now we're ready for our experiments. First, here's one to show you how good a fire extinguisher carbon dioxide really is. Put an empty glass alongside the one with the carbon dioxide. Then light a match and hold it in the empty glass. It stays lit. Then put it in the glass with carbon dioxide. The carbon dioxide puts it out. But you don't have to put the thing that's burning into the carbon dioxide in order to put the fire out. Carbon dioxide is heavier than air, and so you can pour it on the thing that's burning, like this. If you fold a piece of paper into a trough, you can pour the gas down the trough and put out a fire. Carbon dioxide is so good at putting out fires that it is used in many commercial fire extinguishers. These fire extinguishers are filled with a solution of baking soda and water. And up here, there is some sulfuric acid. When someone wants to use the fire extinguisher, he turns it upside down. Inside, the sulfuric acid mixes with the baking soda solution and produces carbon dioxide. The carbon dioxide pushes down on the liquid and forces it out through the nozzle. The liquid, together with the carbon dioxide, puts out the fire. Now, with a few simple things that you can find right around the house, you can make a model of a commercial fire extinguisher, one that produces carbon dioxide and that actually puts out fires. Here's all you have to do. First, put some water in an ordinary milk bottle. Then add some vinegar to it. Then make yourself a stopper like this to cover the bottle with. You can do that by putting 2 holes in an ordinary bottle stopper or cork. In one hole, put a glass stirring rod. In the other, a small piece of glass tubing. To the glass stirring rod, attach a small paper napkin filled with bicarbonate of soda. To the top part of the glass tubing, attach a rubber tube, and to the other end of the rubber tube, the glass part of a medicine dropper. Now, put the stopper in the bottle. And that's all there is to it. Does it work? Well, just show me a fire. There's one. Let's turn over our model extinguisher and shake it up. The vinegar mixes with the bicarbonate of soda and releases carbon dioxide, which presses down on the liquid and pushes it out through the nozzle, and out goes the fire. And now we know much more than we did about that fascinating subject, fire.
Junior Science.